Right. Welcome to my demo. This is a demo about my music composition language, Tonart. So welcome to my demo. Tonart is a language about a language for composing, and it's all about you get a score-like context in which you write an extensible music syntax. So you can think about it as abstract syntax for a traditional music score. And operationally, it feels sort of like a stack-based language, but instead of pushing values onto a stack, you're writing notations onto a music score. And instead of running operators on a stack, you're running rewrites over the score or parts of the score. So you specify score structure, and then you write notations in that structure. And score structure is specified using coordinates. Tonart programs usually have two coordinates. There's voice, which corresponds roughly to the vertical dimension of the score paper, and so which staff the notation will go on. And then there is interval, which corresponds to time, the time dimension, the horizontal dimension of the score. So a beat interval, what beats the notation goes in. To specify coordinates, we use the at form. And this is where we'll start coding, and I will zoom in. Is that big enough? Okay, good. So we use the at form to specify coordinates. And the first subform of the at form is a list of coordinate syntaxes. So you see we've got, as I said, our voice coordinate, we'll say soprano for now. And we've got our interval coordinate, and that's a range, so beat 0 to 4. Okay, and close that. And in here, anything that we write in here, I put the dot, 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 will be inside those coordinates. So in the soprano from beat 0 to 4. So we'll introduce our first notation, and it's going to look like this. And that is our syntax for traditional iconic notes that you see on scores with the note heads and the beams. So we can try to evaluate this form, but it won't work, and that's because this is a Racket REPL, and this is a Tonart program or form. And so Tonart is a DSL that's embedded in Racket. But we need something a process that takes us from Tonart to Racket. It's a compiler is what it really is. And I call that process realization. The reason I call it that is because you've got like Tonart, which is like a notation, it's like kind of abstract, it's like an image, and then you take it to reality. Or actually, in the case of this implementation, you take it to Racket, which is the next best thing. So the form for that is called realize. And this is a form that's an interface between the DSL, which is Tonart, and the host language, which is Racket. And so realize, the first subform, is a realizer syntax, and this is also user-defined and extensible. And so the first one we'll look at is the staff realizer, which is going to try and draw whatever Tonart we give it on a score paper, or make something that looks like it. So we can drop that in there, and you see the note C5 drawn onto a little staff. So a crucial thing about Tonart is that you can take the same piece and realize it multiple ways. And so this realizer, we can use a different one. We'll use the play realizer this time. And the play realizer is going to try and play what you've written out of the computer. Now, we can hit enter here, and it'll look like it's doing something, but then nothing will happen. So sad. The reason that is because realizers have input languages. And the staff realizer and the play realizer have different input languages. It's kind of like if you handed a person like the binary data for a WAV file and said, sing this. What are they going to do? And if you hand the play realizer notes, it says, well, what do I do with this? Play realizer only understands more computational, like computer music-y notations, such as MIDIs, tones, or sound files. So What we need to do is we need to compile our note music into like tone or MIDI music or some mix of both. And the way we do that is through a process called rewriting. So Tonart has these other forms called rewriters, and here's one now, note to tone, which are not notations. They do not go into the score context. They simply transform the score context, then go away. So if we run this note to tone, you'll hear it play a tone. I can only imagine how that came through the mic. And if you run note to MIDI, down here it's actually going to send the music over to, well, it's going to send it using MIDI, which is a protocol, and then I have Grand Org running over here, which is virtual organ software, and so it's listening for MIDI events, and it'll actually play back whatever we do on the organ. So that's fun. So we're about ready to start composing, but before we do, I want to introduce a few abbreviations just to make this easier. So equals is going to be the staff realizer from here on out, and you can see equal, and that's the staff realizer. And bang is going to be the play realizer. Same idea. And instead of writing these cumbersome at forms like this, I'm going to use voice at and then the voice. And I'm going to use I at and then the interval. And if I lost you at all, don't worry, I'm going to narrate it as I go through. Okay, so now on to some composing. So the first thing we probably want to do is give the soprano something more substantial than one note. So we'll try and design a melody. And there's a few ways to write sequences of notes like this. The one that we can do right now that we know is, I at 0, interval at 0, 2, D, interval at 2, 4, E, interval at 4, 6, F. And that's great and all, but it's really, really cumbersome and slow to type. So what I want to do instead for this demo is write down a sequence of notes, then a rhythm, and then use a rewriter to turn that into note music that, for example, the staff realizer can understand. So we're gonna define it. We'll make a little template for this and then fill it in. So define art just means make a binding that contains some tone art and that represents some tone art. And so we've got define art melody. This is going to be our melody. And in here, we'll have a sequence of notes, and some notes will go in there. And then we'll have a rhythm, and some durations will go in there. And then we'll have a rewriter that will apply the rhythm to the sequence to get note music. And so I'm just going to make up some notes that I imagine will make a good melody, and I hope it does, because if it doesn't, then it will sound bad in the end. So we're going to go up a little bit, and then down a little bit, and then up a surprising amount. That's not going to work. Put the right octaves in there. And then we'll stop on this G up here. Make sure those octaves. Yep. All 5. Very nice. And then the rhythm, we'll pick something 2, 1, 2, 1, 3, 3, 3. That should be fine. And that sums up to a total of 3, 6, 9, 12, 15. It's good to keep that in mind sometimes. Okay, so we've got our melody. Let's take a look at what it looks like. So we need to put it in a voice, so we're going to put it in the soprano, and then we'll give the soprano the melody. And there it is on the score paper using the staff realizer. And then we can, of course, play it as well. We can just go back to this, and we're going to use the play realizer, which is bang again. And we have to do note to MIDI so that the play realizer knows what it's doing. And then we can hear it in the organ. Turn that down a little. Lovely. And so that's our melody. Now we want to make a harmony. And we'll do the harmony in chords. So we'll use a very similar template to do exactly what we just did. Define art harmony. And we've got a sequence, but instead of notes, this time it's of chords. Okay? And then we've got a rhythm, and that's going to have durations, and of course apply rhythm at the end to make it into, well, it'll be chord music this time, but we'll deal with that later. Okay, so chords. We got to look at the score and figure out what chords we want. So this, we're going to do a C major. This is like the chords that you learn on guitar. It's these very same chords. So a C major, then a major will work fine, and a D minor, followed by another C major, and then we can do a D major, because that's funner, and then oh, how about an F sharp? No, that's not as fun as I was hoping. A B major. Yes, that'll be good. And finally, we'll end on a C major. And what's up?
It's okay. Let's
Oh, okay. Anyway, yes. So we'll do the rhythm here. 2, 1, and 2 will be fine. And you know what? We'll suspend this into the D, and then how long is the D? 3. So another 2, and then the B major will be 3, and we could go right into the end of that a little, and then 2 there. Okay. So we'll see how this goes. Let's make sure they add up to the same. 3 plus 6, that's 9, plus 6, yeah, 15, great. So there's our harmony. So we'll see if May is right and it doesn't sound good. I think it will sound good. We will see.
Art is subjective, I'm sorry.
So we'll start by showing it. The suspense is killing me. We're going to put it in just a random voice. And the harmony, and then we're going to show it, but as I said before, harmony is chord music. The staff realizer doesn't know how to show chords. We have to do a little bit of rewriting. I promise we'll play it soon. So we need to use a rewriter, and we'll use chord to notes. Makes sense, right? And now the problem is there's a lot of ways to turn chords into notes. So here's a C major chord, but this is also a C major chord, but so is this, okay? So, so we've got a special one. We call it /simple, which does the simplest possible thing. And that is to do this. Make these little, we affectionately call them snowman triads. Triads because there's 3 of them, and snowman because they look like little snowmen. So now we can finally play this. And note to MIDI here. And we'll see how it sounds. I want to turn this off. Make it a little quieter. So what do you think? You know, you can leave a comment or vote afterwards. I think it sounded great. So that's really nice. It's sounding really nice. Now I want to do something a little unconventional. We'll add a second melody, but that's not unconventional. That's normal. But what's unconventional is we're gonna do it out of a mathematical function. So you might be thinking, how are we going to do that exactly? And that's the fun of it. It's creative. But before we do that, we should probably have a way to draw functions because we want to actually visualize what we're doing with them. And so I'm going to provisionally introduce my debugging realizer. It's called the Draw Music Realizer, or DMR for short. And it's a debugging realizer. It will try to draw everything you give it, with mixed results. With mixed results. So here's what it looks like drawing a note. And that's whatever. It's not as good as the staff realizer, obviously. But it does useful things like it can actually draw the harmony, unlike the staff realizer. So that's kind of useful. So anyway, we'll do our function here, and here's a basic syntax. The first thing you think of: function x, sine x. That's our syntax for functions, and the draw music realizer just draws the text for it. Okay. Good try, buddy. So we want to start compiling it into something that makes sense and is more like a note. And I propose the first step as function to contour. And it has to have an x range here, so we'll do -pi to pi. And when we run this rewriter, we get, and I'm sorry for the red on red, again, the DMR is doing its best, but you get the curve for the function drawn onto the score. If you're anything like me, you see that, and you say, it needs to be wavier. So we can use our knowledge of the sine function and decrease the period like that, and now it's wavier. We can do some more, tricks to make it more interesting looking. That's definitely more interesting. So there we go. Let's call it a day there. So we've got our contour music, and now the final step is to turn it into notes. So we'll go ahead and start our template here, define our, and this is going to be melody 2. And we need to actually put it in time somewhere. So the interval from 0 to 15, the same length as everything else. Drop the contour in. And now at the end, we'll do something here. We'll do something here. And at the end, we'll end up running contour to notes, the rewriter contour to notes. So contour to notes needs some context, I would say. And one of those things is the lowest note that it's going to have and the highest note, so a note range, so that it can fill in between along the curve. So that's written as note range. And I'll look at the melody to pick a good note range. It starts kind of low and goes up a little, so we can probably go all the way from like G4 to C5, I reckon. Oh, sorry, G3 to C5. So we'll try that. And okay, so that's our note range. And then we need to give it a rhythm because it can't just do one continuous note the whole time. That's not a note. So we need to tell it like how often to sample from our contour. So we give it a rhythm, and I'm going to use uniform rhythm 1/4, which is just a shorthand for writing rhythm 1/4, 1/4, 1/4, 1/4 for 15 beats, which means we're going to, by my calculation, get about 60 notes out of this because there's 4 notes per beat and 15 beats, 60 notes. And then finally, we need to provide the harmony because it needs to select notes that sound good with the surrounding notes. And so it's actually going to use our chords as context. It's context sensitive to the harmony. So that is our second melody. And if we go back and go to our old composition here, we've got our melody and our harmony, and we can drop in our second harmony. And again, this is just a random voice name. Descant, if you're interested, it's a church music term for a counter melody, like a second melody. So we can draw this, and aha, there it is. There it is. It looks like it, right? It looks like it. It looks also a bit like a caterpillar or a snake. And we can give it a play. Let's give it a go. Note to MIDI, of course. And this is the part where you kind of cross your fingers, say a prayer, and just let it rip. So here we go. That was good there. That part at the end was pretty good. I liked that. So yeah, that was pretty cool. Yeah, I think it's pretty cool. And so just the last couple of things, I do want to show you something I pre-composed using the same techniques. How are we doing on time? All right, a couple of okay, a couple of things. Something I pre-composed using the same techniques. But it's a little more substantial, and it also lets me show you the benefits of having an embedded DSL. So I'm going to use the racket module system to require another composition, and we're going to do, so we'll do prefix in, again, this is racket module system. So this is going to append this little prefix before all the bindings that we pull in from the module, and the module is called toccata.racket. Okay, so we'll pull in this composition, and there it is. And we can take a look. The cool thing about this is we've pulled in different parts of the composition, so we can take a look at just the melody. We need to put it in a voice for this for the staff to understand it. But we'll put it in the and we'll give the melody. And you can see this is the melody. It's actually quite low, so that's kind of interesting. Why is the melody so low? Ooh. So we'll find out. And this module provides a nice sample. Oh, I forgot the prefix. There it is. It provides a nice sample of how the composition could look. And so here it is. And it looks more complicated, but it's using the same exact techniques we just used. This top part is a sine wave being realized by the computer as notes. I changed the ranges a bit as it went along for expressive reasons. this melody is hand composed, and it's actually in the pedal part, so watch out for that. You'll see that it'll actually be on this keyboard down here. And that's sort of characteristic of this is a French toccata style, a French organ toccata. And then this bottom part is in the left hand, and it's the same exact thing. We've got chords, and then we turn them into notes. And I have a sort of chord to note simple addiction, so it's just the snowman triads again. But I hope you're okay with that. So we'll give it a play, and it's going to be default notes and note to MIDI. And let's see how it sounds. Let me make sure the organ is set up for this first. Okay, we'll add that later. This, and this is coupled. This looks good. Yeah. Okay, we're ready. Right, so I hope you enjoyed that. I have one last short thing. I've always wanted to do this since I was a kid. I have to reveal to you that the script for this demo is also a Tonart program. Okay, and I need to let you know that I think I've been doing an okay job realizing it, but I would like to tell you that there is actually a computer realizer for it as well, and so I just want to introduce my my co-presenter here, and here we go. And I'm also going to give him a little bit of counterpoint. All right.
Welcome to my Tonart demo. Tonart is a language for composing music. The major idea behind the language is composition and is like to extensible music notation.
Okay. So, yes, anyway, and so while the credits roll, I just wanted to acknowledge all the software I use, Dr. Racket and Racket, amazing. Chuck is the backend I was using to send MIDI and tones, Grand Org over here. If you're interested in EDSLs and compiling them and multi-language and things, which should be of interest if you're here for this, because all of these languages have been interesting EDSLs. Make sure you get to Michael Valentine's talk on Wednesday at 11:24. It'll be on that exact topic. Finally, I wanted to dedicate this demo to my two teachers, Matthias Felisen and Peter Edwin Krasinski, and thank you all for coming. I look forward to seeing you around the conference.
Everyone can feel free to get lunch, but because what is time, we'll also take questions. I'll go ahead and start. It seems like you cheated there.
I did.
In the sense that pitch classes are not determined by what you're writing in the melody, but rather their function with respect to the harmony.
Pitch classes are not related to the melody. Yep, that's correct. Yes, exactly. I did. It's not cheating. It's a choice.
Okay.
Yeah.
If I wanted to differ from that, let's say that I wanted to insist that the first two C's in the melody are really the pitch C and not just whatever the analog of C is in the current harmonic moment. Can I do that?
Not with this realizer. But not with this rewriter. But you can write your own rewriter. This one is actually very simple as well. It does, like, for a major chord, it uses a major scale. For a minor chord, it uses a natural minor scale. If you were doing it for real, you would look at the surrounding chords and try to interpolate what accidentals you should use. So there's definitely more work to be done on that rewriter.
Okay, and I could write my own realizer that says, screw the surroundings, I'm post-serialist, I do what I say I do.
Oh yeah, absolutely, absolutely. That's what it's all about, baby. All right.
Cool, more questions? I think it's lunchtime.
Great.
See you guys all at the room.
Sure.